About domain really quickly, and then we'll do a couple sample problems for this. Okay, remember, when you're dealing with domain and the restrictions on a domain, there's a couple that you need to pay careful attention to. First is, if I just gave you an expression, okay, or a polynomial, and I asked you for the domain of this, the domain itself, when there's no restriction on what the value of x can be in something like this. Okay, so x can be a negative number, it can be 0, it can be a fraction, it can be a positive number. Okay, any real number will work for x and still give you a real number when you evaluate it. So the domain for something like this is just all real numbers. So remember, if you're designating this online, your options are either just the letter R to represent all real numbers, or you can use interval notation, which extends from negative infinity to positive infinity. Okay. Now, it may be the case that I give you a specific expression, right, and then at the end of this expression, it extends a specific restriction. Okay. So it is possible for a restriction to be given. If that's the case, then your domain is all real numbers, and then whatever the restricted value is. So x is less than -1. So your two choices for this, you can either write it in this the inequality form online, which would be r comma x less than -1. Okay, or you can write it in interval notation. If x is less than -1, then -1 is our upper limit, negative infinity our lower limit. Neither one is actually included. And so that would be your interval notation. So again, either of those forms would work when you enter it online. Okay, now, another type of domain restriction you need to be aware of is one that's embedded within a formula. Okay, what is this the formula for? 1/2 pi r squared is area of semicircle. Good. Okay, so in looking at that, the fact that this is a semicircle means, how is the domain restricted on this? It can't be a negative. Okay, can it be 0? No, so it has to be a positive number. So to designate a positive number, all real numbers, x has to be greater than 0. Again, if you have 0, it means it doesn't exist. So in order for that physical element to exist, you do need to have a positive radius. And so when you designate this online, once again, it's a interval solution. So your answer could be r comma x greater than 0. Or you can also write it in the interval form. Your lower limit here is 0, your upper limit infinity, never equals infinity. In here it's not included, so you'd have a parentheses once again. Okay. In addition to this, if you have an even indexed radical, there again remains some restrictions that have to be taken into consideration. And that is your expression that's inside any even index root. So that could be a 4th root or a 6th root. It can never be a negative value. So in order to solve this, what you would do is take your expression, set it greater than or equal to 0, and then solve. Okay? So again, these will always be real simple to solve. Okay, just here subtract a 1. So you get your domain in this case to once again be all real numbers. Here x is greater than or equal to -1. So you could designate that as r x greater than equal to -1, or in interval form, your lowest limit is -1. Your upper limit is positive infinity. -1 is in fact included, so you have a bracket there when you write your intervals. Right, the final step is a fraction. If you have a fraction, you have to account for restrictions. And so in looking at this, the domain restriction, again, it can be all real numbers, but here when there's factors in the denominator that are equal to 0 or can equal 0, you have individual restricted values. So when you have restricted values, you set the factors equal to 0. So if, in this case, x plus 1, set it equal to 0 and solve, that becomes your restricted value. So x can be all real numbers as long as it does not equal the values that would make it or give you division by 0. So here, we're not going to use the inequality form for this, or I'm sorry, an interval form for this. We're only going to use the inequality form, which is all real numbers, x not equal to, and remember, equal slash equal is not equal to, and then the negative. I want you to try to figure out what would the domain be for that expression. When you look at this, okay, you have to look at all the parts. So there's two parts that are coming into play here. There's the radical part, and then there's the fraction part. So the radical part tells us that x has to be greater than or equal to -1, correct? And we saw that on the other slide. Okay. But the fraction part says, can it actually equal 0 in this case? No, so we have that additional restriction. So now it can't just be greater than or equal to 0, because we know if it was equal to, we'd have division by 0. So you have to change it to just greater than. And so again, when you identify this online, you can either use the inequality form, or in this case, the interval notation will work just fine as well.